Okay, so our next example here is again with a normally distributed population with mu is equal to 45.3, sigma is equal to 6.1. We want to find the probability that a data value from the population, an x value, falls between, remember the extended inequality is the mathematics way of working with the notion of between. We have 38.5 is less than x is less than 59.1, or simply put, x is between these two values. So, again, a normally distributed population means we draw the normal curve with the two axes as usual. Mu, we're given to be 45.3, and the standard deviation is 6.1. All right, and we want, let's see, this is the x scale, this is the z scale. We want 38 and 59. Well, here's 45. So 38 is over here to the left somewhere, 59 is to the right somewhere. So I'm going to put 38.5 and 59.1. And as long as we have them in the correct sequence, the specific distance doesn't matter. And what we want to find now is the probability of obtaining an x value that falls in that interval. If you direct these vertical lines now, remember the arrow always goes to the left. The arrow always goes to the left. I'm going to change that color. So the arrow always goes left. The arrow always goes left. All right? What we want to find is this area, the area under the normal curve between those two vertical line segments. All right? So the task is the same as before. We have to find the z-scores, find the table values, and then we're going to do some arithmetic. So first is to find the z-scores. We know z is equal to x minus mu over sigma. So let's call z-score number 1. We have 38.5 minus the mean 45.3 divided by the standard deviation is 6.1. And that works out to be, I've actually computed this already, that works out to be negative 1.11. Let's do a specific computation. If we have 38.5 minus 45.3, be sure to hit equals and then divide by 6.1. Remember, we're going to round to 2 decimal places, and so I have negative 1.11475, yada yada, and so that rounds to negative 1.11. And that goes here. 38.5 on the x scale corresponds to negative 1.1 on the z scale. And then for z-score number 2, it's the same notion. Now I'm using 59.1. Subtract off the mean, divide the standard deviation, and I've already worked that. That works out to be 2.26. Now, you should make sure that you can make your calculator find that value. Make sure you take 59.1 minus 45.3 and then hit equals and then divide by the 6.1. An alternative, if you're if you know how to work with parentheses on your calculator, you can put the numerator in parentheses and then you don't need to hit the equals in between. But either way, you should be able to find the 2.26, and that goes here. And so now we take the table, the z table. The table value for negative 1.11, negative 1.1, 1, make sure you don't use the 0 column, use the 1 column, negative 1.11, the number I have is 0.1335, 0.1335, table values here. 0.1335. And then if we have 2.26, 2.26, I'm coming up from the bottom of the table because it's closer there, since this table is so expertly designed. 2.26, the value we have is 0.9881. 0.9881. So now we need to make sure we know where each of those values belongs in this picture. The the 0.1335 is the table value for negative 1.11. The table value always goes on the arrow, and the arrow always goes to the left. And so what we found here is the 0.1335. That corresponds to this little area, which is a region we don't want. We do not want this area. We want the blue area. So put that on hold for now. The next piece we have is we have the 0.9881. That's the table value for 2.26. That goes on the arrow here, 0.9881. Now what does that correspond to? That corresponds to everything from here all the way down to negative infinity. That corresponds to this purple region. Well, I think we can see what we want. The purple gives us too much. Too much by what amount? It's too much by precisely this red piece is the bit we don't want. And so, to find the probability of the blue, we take the purple, remove from it the red, that leaves the blue. And so the probability we want, so the probability that 38.5 is less than x is less than 59.1 is given by the purple large number 0.9881 and subtract from that the red piece we don't want, the 0.1335, and that should give us the amount that we do want, the blue, and 0.9881 minus 0.1335. The amount we want is 0.8546 is equal to 0.8546. So the area between two values, you find both z-scores, find both table values, and then always compute large probability minus small probability. It's large number minus small, so the value you get is the probability of lying between those two given x values.